This is the Math 8 unit test on functions and relations. Number 1A, tickets to a concert cost $20.50 per ticket. What is the independent variable? Total cost, $20.50 per ticket. Number of tickets. 1B, tickets to a concert cost $20.50 per ticket. What is the dependent variable? Total cost, number of tickets, $20.50 per ticket. Number 1C, identify if this scenario would best represented by a continuous or discrete graph. Tickets to a concert cost $20.50 per ticket. Is it continuous or discrete? Number 2A, on your bike, you can travel 6 miles per hour. What is the independent variable? Time, or the number of hours, miles per hour, or total distance, number of miles. 2B, on your bike, you can travel 6 miles per hour. What is the dependent variable? Miles per hour, total distance, or time in number of hours. 2C, identify if this scenario would be best represented by a continuous or discrete graph. On your bike, you can travel 6 miles per hour. Continuous, discrete. Number 3A, Justin Bieber earns $10 per driveway he shovels. What is the independent variable? $10 per driveway, number of driveways, total money earned. 3B, Justin Bieber earns $10 per driveway he shovels. What is the dependent variable? Number of driveways, $10 per driveway, or total money earned. 3C, identify if the scenario would be best represented by a continuous or discrete graph. Justin Bieber earns $10 per driveway he shovels. Continuous or discrete? Number 4A, you have to identify the relation. Okay, I will give you the ordered pairs for each of these points. A is 2, -3. B is 4, -3. C is -4, 2. And D is 0, 2. Which of these 4 options represents this graph as a relation? For B, you're using the same ordered pairs and identifying which mapping diagram matches it. So again, A is 2, -3. B is 4, -3. C is -4, 2. And D is 0, 2. So which of these 3 mapping diagrams matches that? Number 5, write the domain of the relation below using no spaces and correct notation. The domain. Your ordered pairs are 2, -3, 4, -3, -4, 2, 0, 2. Number 6, write the range of the relation below using no spaces and correct notation. Your points are, starting from the left, is -2, 4. Moving down, -1, 1. You have the origin, 0, 0. Now moving to the right, you have 1, 1. And the one furthest right and up top is 2, 4. What is the range? Make sure you follow the rules for domain and range. Number 7, write the range of the relation below using no spaces and correct notation. Again, the range. If you need to use a number line to order these from least to greatest, I would highly recommend doing that. Number 8, write the domain of the relation below using no spaces and correct notation. For numbers 9 through 12, you're going to use the function rule y equals negative 2x plus 1 to find the y values for the given x values. You will put the ordered pairs for your answers in the questions below. So when you have the function rule y equals negative 2x plus 1, and you substitute the x for negative 2, what do you get for the y? Number 10, same equation. This time substitute the 0 in for x to find y. Number 11, again the same equation. This time substitute 1 in for the x. Number 12, again with the same equation. This time substitute 3 in for the x. Number 13, water is flowing into each of the vases below at a steady rate. Match vase 1, so match just this vase, with the graph of the height of the water as a function of time. Choose which one graph letter best matches. So vase number 1, which graph matches vase 1? A, B, or C? Number 14, match vase 2 with the correct graph. Match vase 2 with the correct graph. Number 15, match vase 3 with the correct graph. Be very careful with these because if you get one wrong, you automatically get 2 wrong. Number 16, a container is filled with water in 5 seconds. The graph shows the depth of water or height of the water in the vase as time passes. The water flows into the container at a constant rate. Which diagram represents the container? So you're looking for a container that has a constant rate. Is it option 1, option 2, or option 3? Number 17, is this a function or not a function? Number 18, is this a function or not a function? Number 19, is this a function or not a function? Number 20, is this a function or not a function? 21, is this a function or not a function? Number 22, is this a function or not a function? And number 23, is this a function or not a function? The input, a grade in math class. The output, people in this class. Is it a function or not a function? Number 24 is a speed graph. Notice it's a speed graph. So the higher up you go, the faster you're going. Beth and Tom start out together and hike along the same trail, but walk at different speeds. Is Beth or Tom walking faster at 20 minutes? Use the graph below. This is a speed graph. So who is walking faster at 20 minutes? You can't tell? It's Tom or it's Beth. Number 25, Beth and Tom start out together and hike along the same trail but walk at different speeds. Is Beth or Tom ahead at 10 minutes? Note this is a speed graph. At 10 minutes, who's ahead? Beth, you can't tell, or Tom? Same graph. What is happening exactly at 40 minutes? Again, this is a speed graph. So what is happening at this point right here at 40 minutes? Is it Beth and Tom are walking at the same speed? Tom meets up with Beth on the trail, or Beth and Tom take a break for a second? Number 27. Every morning, Jason Derulo walks along a straight road from his home to a bus stop, a distance of 160 meters. The graph shows his journey on one particular day. Are there any sections that are linear? If so, how many? No. Yes, there's 1. Yes, 2. Yes, 3. Yes, 4. Number 28. Choose the statement that best matches with the graph below. So here you have a graph. Looks like an upside down V. The price of buying candy when charged per pound. The population of a species when predators are dying off. The distance from home when jogging around the block at a constant rate. Or the height of a water balloon launched up and off a boat dock. Number 29. Choose the statement that best matches the graph below. This is process of elimination, so whatever one you chose up here, probably not going to use twice unless you got it wrong and you can't decide. Does this graph represent the height of a water balloon launched up and off a boat dock? The distance from home when jogging around the block at a constant rate? The population of a species when predators are dying off? Or the price of buying candy when charged per pound? Number 30, match this graph with the scenario. The population of a species when predators are dying off, the price of buying candy when charged per pound, the distance from home when jogging around the block at a constant rate, or the height of a water balloon launched up and off a boat dock. 31, match this graph with a scenario. The population of a species when predators are dying off, the price of buying candy when charged per pound, the height of a water balloon launched up and off a boat dock, or the distance from home when jogging around the block at a constant rate. Number 32, you're going to match the graph with the scenario. Make sure you notice this is a distance graph. It's a distance from home. So if I look at these, all 4 of these start at home. Each morning, Brad jogs to school at a constant rate. Which graph best models this scenario if the dependent variable is distance from home? So jogging just to school. Is it option A, option B, option E, or option F? Number 33, choose the correct graph that matches the scenario. The temperature on a very cold January day where it increases at a constant rate, maintains temperature throughout the day, and decreases temperature at a constant rate at night. So along the dependent variable of the y, you have temperature over time. Is it option A, option B, and option C? A note to the y's, you're looking for constant rate. Number 34, be careful because this is a speed graph. Okay, so you're going to match this picture or the route of this toy car on a racetrack with the correct graph. So the car goes down this loop. Think about its speed. And then it goes up this loop-de-loop. Then it comes down again. And then it goes up and it comes down a little bit. So think of speed. Is it A, B, or C? Number 35, Mia paddled her canoe from the shore of a lake to an island. She stopped on the island to eat lunch, and then paddled her canoe back to the shore. Hint, this is a distance from shore graph. So distance from shore. So here she's at the shore. She's moving away. What happens here at the horizontal line? And then it comes back. So which of these statements are true? Mia paddled a total distance of 3 kilometers over the course of her trip. Remember, she goes there and back. Mia paddled the canoe for the entire 100 minutes of the trip. Or last, Mia paddled faster on the way back to shore than on the way to the island.